Hello guys, welcome back to our channel. Today we are going to discuss about what is the JK flip-flop and how to make the Verilog code for this JK flip-flop. In the previous video we discussed about the SR flip-flop. In the SR flip-flop we have a problem that if we give the S and R, that means the both inputs have logic 1, then the state will be not used or it is an undesired state, because at this stage the outputs are both are equal, that means q and the q bar will be equal, but it is not possible because q and the q bar will always complement to each other. So this drawback will be avoided by using the JK flip-flop. Today we will see how the JK flip-flop overcome the problem of the SR flip-flop. So here you can observe that this is the SR flip-flop truth table. If you want to know how this truth table obtained, you can refer previous video which is already available in our YouTube channel. And this is the SR latch truth table. This is the SR flip-flop. To make this JK flip-flop, just connect the Q bar output to the J input and the Q output to the one of the input to the K NAND gate. Okay, here except this case, remaining all the cases will be similar to the SR flip-flop. Only this particular condition change in the JK flip-flop. Let us see how it will be changed in the JK flip-flop. Okay, so for that I am giving J clock and K are 1, and suppose I am assuming that Q is 0 and the Q bar is 1. I am just assuming this. Now the Q bar will be applied to this. Here the value is 1 and the 0 will be applied to this K gate. Okay, here 110 the output will be 1, here 111 the output will be 0. Here this is a SL latch, right? If the inputs are 0 and the 1, that means 0 and 1, what will be the output? 1 and 0. Okay, now again this will be applied to the these gates. Now the here 0 will be applied, here 1 will be applied. Now here the output will be 1 and the 0. Now if we apply 1 and 0, here 0 and the 1. In this way, here we will not get the undesirable state, but we will get the toggle state. That means the outputs are continuously toggled. Here you can observe 0 1 0, here 1 0 1. In this way the JK flip-flop will be work. And now we will see how to make the Verilog code for this JK flip-flop. Okay guys, now we will start making the Verilog code for the JK flip-flop. So nothing but a module. I am defining the module name as JK flip. And here what we require input I am taking as the input reset, clock, J and the K, and the outputs require output register, because it has to remember the previous day, so that according to the based on the inputs it will change the next state. So output is to Q and the Q bar, and I am closing this. Now I am using the always at the rate command. It will follow the pause edge clock. Pause edge clock. That means if the positive pulse of the clock is appeared, then only it will be work. Otherwise, it will be ideal. Begin. Now, if reset equal to 1, then begin. Y will be 0. Yes, y will be 0, and sorry, here we take the q, right? So q equal to 0, and the q bar will be nothing but the complement of the q, right? So I'm ending this. Else means if reset is equal to 0, that means it will follow the clock pulse, right? So now if j equal to 0 and also k is also equal to 0, then what will be happen? Q will remain in the same state. Q less than will be. Here you can observe that Here we are using the less than or equal to. This means it will be it will be store the previous condition. Okay, and the q bar will remain as the same. Okay, and else if j equal to 0 and k equal to 1, then begin q will be 0 and the q bar will be nothing but the complement of the q, right? So I'm writing this and I'm ending this. Now else if here j equal to 1 and k equal to 1, sorry, k equal to 0, and nothing but the begin. Now the q value will be 1 and q bar will remain as the same like as the previous q, and ending this. And finally else begin. If that means if j and k are both are equal to 1, then q is nothing but the complement of the q and q bar will nothing but the complement of the q bar. Okay, and I'm closing this and module. Okay, this is the design code which will be required for our JK flip flop. Now we will write the test bench code for this JK flip flop. Okay, module DB register. What we have register clock J and K, and wire. What were the whites available? Q, comma Q bar. Okay, yes, Q comma Q bar. And I am extracting the inputs and output from the design code JK flip 1. What are there? Okay, comma clock comma J comma K comma Q comma Q bar. Okay, initial begin. Yes, here I am writing the dump file command which will be used to display the graph file file.vcd and dump vars. Here I am initially considering clock is equal to 1 and I am using the forever command. That means clock is equal to complement of the clock. That means until and unless for every, we can also set the delay for a hash 10. That means every 10 seconds automatically the clock will be changed to the next day. That means if the clock currently if clock is 1, it will be changed to 0 and then it will be changed to 1 and it will be changed to the 0. In this way the clock will be changed continuously until the program execution stops. Okay, now ending this, and now I will give the normal test bench and I am initially considering reset is equal to 1. Here I will give j equal to 0 and k equal to 0 and I am giving just time delay of 5. Okay, now I will start giving the reset is equal to 0. Okay, now I will give j equal to 0 and k equal to 0 and I am giving the $5. Here if you want to observe the clear outputs, then you have to give the 2 times in the test message, because here what we have to get one positive cycle and one negative cycle. Here the in the negative cycle the device will not be work. So I am giving 2 times. That means if it is present in negative cycle in the one time and the next time it will be present in the positive cycle, then the function will be continued. I will show you at the output clearly, then you can understand more. And next j equal to 1, k equal to j equal to 0, k equal to 1, and I'm doing the alpha, and again I'm copying this. Okay, now I am giving another sequence k equal to 1 and the k equal to 1, and again I will give you as a j equal to 1 and the k equal to 1, and I will give another two sequences also same one. Okay, now the test bench is completed. I will giving a dollar finish. I'm giving the end and end module to finish the test bench. Okay, now I'm selecting the one of the tools on the simulator to run this file. 0.9% I'm selecting, and I'm selecting the preview. I'm saving this file, and I'm gonna run this. Before that, I will give some name called JK Flipflop, and I'm going to run this by pressing the Control plus Enter command. As we have got the output right, let us verify whether it is correct or not. Yes, here you can observe that if the main is red, if j and the 1 can both are high, here we can see that there are toggle states. Here 0 and the 1, that means q is 0 and the q bar will be 1, and when the both inputs are high, the q and q bar will be complement to each other, and again q and q bar will be complement to each other for the continuous input. So in this way we can design the jk flip-flop. I hope you understood this video very well. If you not understood, please mention in the comment section. Thank you for watching this video. Please stay tuned for the next video.